Hello everyone. Today we'll be creating the original Snake game in C++. This is a great project for beginners since it doesn't require a whole lot of code, but the final product is something fun to play with. The coding projects you typically do in class are boring, so today we'll be creating something fun. To start with, you'll need an IDE. I'm using the Writer IDE because I think is the best one out there currently with many tools to help you code. You'll also need a Windows computer for this project since we'll be utilizing the Windows library to create our game screen. For more advanced projects, we would use OpenGL since it is a cross-platform library, but it's also more complicated and requires more setup. So for today, we'll be keeping it simple and using the Windows library. I've already created a Snake game project with a few classes that we'll be using to write our program. So to start, you go and create these classes by right-clicking on your project and adding class. My Snake game class contains the main function, since this is the class that will be connecting everything together. You'll also have a graphics class to handle drawing to the screen, and a snake class to remember what our snake is doing. Now with that out of the way, let's start coding. So to start, we're going to be creating the graphics engine so we can have something drawn on the screen. To do this, we are going to need to include the Windows library, and we're going to need to create a screen. There we go. Now I'm just going to speed this up a bit while I write this out since it's a bit. Okay, now that that's done, here is our create screen code. There's a lot going on here, but you can just copy and paste what we have here. The important parts are the text right here. This will be at the top of our window, so I just put snake game there. And this would also be the dimensions of our window. I put 1000 by 1000 since that's just on most monitors. And yeah, that's pretty much it. Just copy this, and then we're gonna head to the next code. Next, we need to actually draw now. So we're going to create a draw screen function. And because we need these two functions interacting, we will actually need to make this a global variable. So this will be very important for our graphics engine because it contains the instance of our window. So we are going to copy this and put it up here. And I like keeping my variables separate from my functions just so it looks neater that way. Have a variable there, and in C++ we also need to include it up here with our class like this. If you don't have this, you will get an error. And now we can use this instead. Now we create a draw screen function. And now I'm going to write the draw screen code. Now with this code created, we can now draw to the screen. So the way Windows works is it has a messaging system, and you have to send the library a message, essentially, of what you want to print onto the screen. So that's what I have set up right here. We are going to peek at the message, and if the message tells us to quit, then return false. Otherwise, we're going to translate the message and execute it. So now we need to create another global variable because this is something we need to keep track of for later. So I'm going to copy this just like before. Now that we have this, we actually need to draw something. So to start, let's just draw a blank screen. Since this is something we'll be doing a lot, since we want to do this every frame in order to clear the frame for the next frame, we're going to write a clear screen function. Now that we've written the clear screen function, we can now call our create screen and draw screen in our main function. So I have that placed in my snake game, and I recommend you do the same. So this is where our program will start. And right now, if we run the program, it's just going to run this code and return 0. So it's not what we want. We want to call our graphics engine. To do that, we need to first include it. And because I made everything static, I can just call graphics engine dot, oh, not dot, create screen, and then draw screen. And because we want to do this over and over again, for now we're just going to do while true, but we will clean this up later. After writing this, we need to go back to the graphics engine because I forgot to add the window proc function. So this is a callback function we'll be using for our graphics engine, and this will be called every frame to draw onto the screen. So here we go. This is what we need for now. We have a destroy message. So when this destroy message is passed, then we just quit the program. Otherwise, if we get the paint message, then we will paint onto the screen. Next, we go down here and we also need to add this release DC code to release every time we draw the frame, and then finally return true at draw screen. And let's run the program. Here we go. Okay, it's a bit big for my screen, so maybe 1000 is too big, but here you go. Now we have a white screen. Now we should actually define a constant variable up here. Screen width, yeah, let's make that like 600, but adjust this for your own computer. Okay, now we can start painting our game on here. So the way the snake game works is there's a snake and it goes through a grid-like structure. So we are going to need to draw that grid on the screen. And we also need another constant variable, constant, call this game size. And we'll start like 8. So this means it'll be 8 squares across, 8 squares down. So now we're going to draw the grid. We're going to have this in a separate function that we call in our snake game. So we're going to draw, no, actually, we don't want to call that there. We're going to call that here. So after we clear the screen, we're going to call draw grid. Now we're going to need a double for loop to draw all of these lines. Actually, first, we are going to need to have rectangles. So we are drawing a rectangle here, but we need to better define where we want the rectangles drawn. So we're going to have to write a helper function for this. So in order to draw our grid, we're going to write a draw rectangle function. We're going to need a rectangle, but also a color. So we are using this color reference variable, which defines red, green, blue for our color. Now we can draw this rectangle. And there we go. Now we can draw a rectangle. So now we'll go down here. So we're first going to draw the vertical lines down the screen and then the horizontal lines. Is that right? No, I think we need this. Now we should define the position for it. So for the vertical lines, we need to find the X position for where they start. And how wide? So we need to figure out the spacing of these grid lines. So basically, we need to get the width of the screen and divide it by the number of tiles that we want. However, we run into another issue because the window screen we are drawing has borders on the top and the sides, which are also included in that resolution we define. So we also need to subtract that out. So first, we are going to need to keep track of the width of the screen and the height of the screen, of the drawable screen, I should say. Here we go. And we are going to be defining this here in the create screen function. So the width, okay, no, that's not right. Don't always use autocorrect. So we will be using the client rect again. And the client rect is the drawable area. Here we go. Client rect right over our game size. And then it's pretty much the same for the height. This would be bottom. And now we have our square width. There we go. We can draw the rectangle now. So now let's see what this does. It does nothing. Oh, and the reason why we are getting the wrong GC is because this was incorrect. There we go. Now we sort of have it drawing on screen. You'll notice that it's flashing, and you'll think we did something wrong, but we actually didn't really do something wrong. We just forgot a step. So the reason why it's flickering like this is because if we look at our draw screen code, gets the message, gets the handler, it clears the screen, so the screen turns white, and then it runs the code to draw all of our rectangles. And if our monitor refreshes in between these steps, we'll see a blank screen because our monitor will refresh and see, oh, there's a clear screen. I'm going to draw a clear screen. And then later, we draw the grid, which is an issue. We do not want our game flickering like this. So in order to solve this, we'll need to do something called double buffering. And what this means is we will create our rectangles and draw them onto a virtual screen, a separate screen which we can't see, and then we're going to copy everything. So in order to do this, we are going to have to refactor our drawing code. So to start, we are going to have to write a new buffer to store all this to our grid, and we'll be passing this in to our rectangle. And we will be using this one instead for everything. And so when we draw the grid up here, we're going to have to make a copy. In order to make a copy, we will need to do this. Yeah, I think that's correct. Yes, that makes a copy. There we go. Now we're going to clear our screen, draw our grid using our copy, and then we will need to replace it with the one on screen. That's what this function does. Yep. And then we're going to clean up because we do not want to have any memory problems. We have to delete what we just created. We also need to clear our screen using this as well. And there we go. Look, no more flickering. So now we can finish our drawing grid code. So now we have to draw the horizontal lines. And there we go. Now we have the grid. Cool. So this is the first step for our snake game. Now our next steps will be to create our snake and have it spawn in at a location, and then we'll spawn in our food and finally have it move. So now we get the exciting part of creating our snake. Now we have to decompose what the snake actually is in the game. So the snake is a series of positions on the grid. So to do that in code, we will need to create a vector, because this is just a complex list, essentially, that we can perform complex operations on in C++. And to keep our coordinates together, our x and y coordinates, we are going to use a pair instead of having two int variables. And now our snake also always has a direction. So we are going to write a direction in the form of a pair as well. Nope, not food. Direction. And it also has a size. But I guess the size is always equal to the snake, so maybe we don't need that. And we can also define a color for it, so we can make our snake any color we want. Yep, I think this is good for now. And now we are going to write our constructor for our snake. And the constructor is called every time we create a new snake, so we want to know what we want to find. So our snake can be any color we want, so we want to pass in the color. And the position, we can just define ourselves in the snake class. So we can have it just at the top left corner and give it a direction. So this color is equal to the passing color. This positions, not called positions, it's called positions. Not to be confused with snake. Positions is equal to well, yeah, we don't assign vectors actually. So this positions dot push back make pair, and this will be the first position that it's at. Since our snake just starts as one long, we just need one position there. And then when you give a direction, I'm gonna say make it go right. the positive x direction. It doesn't like, oh yeah, I know this. And actually, we can go ahead and use namespace st. And so by doing this, we can actually remove these, make our lives easier. Type that out every time. And I only recommend using namespace inside of the CPP files and not the header files. There's some complex reasons for that, but basically your program could crash under certain circumstances. It's just extra debugging we don't want to do. So just keep in the CPP files and you'll be good. Next, we need to draw our snake. So I think we want this in our draw screen function. So go back to the graphics engine, and we want the snake to be, I guess, behind the grid because we don't want any of the snake to appear on top of the grid. So we are going to call draw snake here. Let's just create that function real quick. And since our snake is a square, we can actually define a square function. So we're going to go over here, and next to our draw rectangle, draw square. So we need a position. And then the color of the square. Hello. There we go. Cool. So now we can generate a rectangle based on our position. And it'll just make it easier instead of having to generate the rectangle ourselves each time, since a square is easily defined. So here in this function, we need to draw a square for every position in the snake. So to do that, we are going to get every pair from our snake. So now that we have this, we actually need to create our snake and our snake game. So go to our header file, and we'll create a pointer to a snake. And the snake game, we can create it. So after we create the snake, actually we can do it before. Snake equals new snake. And we make this static. There we go. And we're going to pass in a color, RGB. What are we thinking? I'm thinking like an off red color. So red is first. So 200, 80. But you can do whatever you want. Say it could be any color. So now that we have the snake created, we can go back to our graphics engine, get the positions, and I did that wrong. And you get snake color. So snake game, snake color. Oh, we got a couple errors. Yes, this is what I was talking about earlier. We didn't define our snake at the top of the CPP file, and it gave us an error. Just gotta do this. There we go. Now we have our snake. Unfortunately, it is going over the square a bit, so it looks like we need to adjust one of our functions, probably our generate square function, because we do not want it overflowing to the next square. We forgot about the square height, because the height of the square is, or the height of the screen is actually different from the width of the screen because of this top bar right here where we at snake game. So when that's fixed, we now have our snake. Now we can just as easily create our draw food because our snake needs some food to eat. Why'd you do it there? Yeah, we'll put this right below draw snake. But this is much simpler. We will need a position and a color though. Let's make it a bit green because snake to eat healthy. Say 20, 220. That'd be a greenish color. And now we need to get a position. So the food will be at a random position at the start, and then every time the snake eats it, it will need to change positions. So this is something that should happen in our snake game because this is where most of the logic happens. So now we're going to create a position for the food. So see pair food position. And we should write a function for this. So let's write generate food. So here in this function, we are going to assign it to a random position. And then it will need to be by the size of the grid, which we defined as game size here. So we actually, I think it's actually best if we put the game size in the snake game. I think it makes more sense there. And we will need to make this a static variable as well. And I think we leave that there. So now we have the game size, mod by the game size. Do the same for the y. And at the start of our game, we will also need to set the srand. So this is our random number generator that comes with C automatically. And we are going to pass in the time. And so what this will do is every time you run the program, it'll be a new random number, since we don't want the food starting in the same position every time you load the game. So that's why this is important. And then this over here, the random right here gives you a random number from 0 through whatever the max integer is, like 2 billion or whatever. And then it mods it by the game size. So this means the random number generator, instead of being from that big range, will now be from 0 through whatever this is. So now that we have a random position for our food, we can come back over here. Oh, we have to fix this. So we moved our game size. Now we can get our food position. After that, we actually need to set our food. So we need to call generate food. And it'll give it a position. And after adding the generate food, we need to come back to our graphics engine and draw our food. So we'll do draw food right after our snake. And run the program, and there we go. Now we have a snake and a food. Now we do not want the food generating where the snake is right now, because that'd be too easy. You have to draw the food somewhere else. So we actually need to modify this function. So instead of sending it to the food position directly, we are going to put it in its own variable. We'll call it next position. We'll say while food position dot first is -1. And the reason we're doing this is because we know the food position in the game can never be -1. So we are going to initialize it as such. And so while this is at -1, we are going to attempt to change it. But now we need to see if this food position, if next position is at one of the snake positions. So we now need to write a function in the snake to determine if it's at this position. So we'll write bool is snake at position, and then we'll give it a position. And now we need to loop through every position in the snake to see if it's there. I'm not sure about the equality on pairs. I'm not sure if this is actually a valid comparison, so I'm going to do it manually. .x equal position dot first. First. So if the first position is the same and the second position is the same, then return true because the snake is at this position. And we're doing this for every position in the list. Yeah, that's fine. So now that we have this function, snake is snake at position, next position. Well, actually, if the snake is not at this position, then the food position would be set to next position. And since this will never be -1, this loop will end. So now, nothing should change, but we can now guarantee the food will never be at the snake position. So now this is our game, but it's not really much of a game. We can't really do anything. This is just a static image. So what we need is controls. So the next step of our snake game is to add key input. And you can bind any keys, but I go with WASD because that's what most games use nowadays to move around the snake. So this is to be something in our graphics engine. Since we already have a callback function to interact with Windows, we might as well just continue using this function that we've already made. So after we check for the paint command, there's another command called WM key down. No, not WMK. WM key down. And now we need to detect which key is pressed. So, oh, sorry, showing me. So like if escape is pressed, we probably want to quit. So we can go ahead and use this code up here. If wparam is equal to W, so this would be the W key, and I believe it does have to be capital. Why doesn't it like that? Oh, because it's double quotes. You have to use single quotes for chars. So single quotes, not double quotes here. And so now, if this is pressed, the W key is pressed. And we're going to do this for all. WASD. Now we need to write our movement functions. So we go over to our snake class and we need to add functions so the snake knows what to do when we press a button. We'll use our direction. So we'll set our direction, make pair. So moving up. So remember how I said it draws from top to bottom on the screen? So because of this, moving up, we actually need to set this to -1, which definitely looks weird, but if you don't do this, you will not be moving correctly. And then move down would be +y, right would be +x, and then left would be -x. And so we still need the move function, but we're not going to pass anything in because we'll be using our direction. So for now, since we only have a single guy, we can call positions, at 0 is equal to make pair positions. So this is the current position, but now we need to add the direction to it. Direction dot first and direction dot second. So now every time we call this, it'll change the position to its current position plus the direction we're moving in. And we will need to modify this in the future when we have a bigger snake, but since our snake is only 1 long, this is good enough. Now we need to call this, well, we need to call these functions we just created up here in our keybinds. So this would be snake game, snake, move up. And the rest of the functions here. But now we actually need to move the snake. So in order to do this, this would be something after our draw screen. But this is where it gets more complicated because this function's running many times per second. But we don't want the snake moving that fast. So we have to be smarter about it and write a function to calculate how long each frame is in order to know when we need to move next. To do this, we will create a frame duration. We use something called chrono, which has lots of time functions in it. No, not this. And what this will do is the frame duration, I'm setting it to 60 frames per second. You can change this if you want to, but I think this is optimal for our game. And so now we need to measure time, basically. So I'll create a start time variable. And this will be the current time. Why doesn't it like that? There we go, start time. And so now we're going to call, actually this should be outside the while loop. And then we're going to have another time variable, frame start. We measure it again. And we actually need to utilize the Boolean for our draw screen now, because we want to quit out of the loop if this returns false. And now we're going to call snake game snake. But we don't want to just move it like this. We want to get the current time. This will be this. And figure out if enough time has passed in order to know if we can move the snake. So we will get the elapsed time using the duration. If elapsed.count bigger than so now we have to decide how long we want it to wait. So this would be our game speed. So I'm going to create another variable. This would be a float game speed, and this is how hard the game is. Because if the game calculates movement faster, then the snake moves faster, and you need to have faster reaction time. This is totally adjustable to your needs, but I think 0.3 is a good time. It's a good reaction time for players to move around with. So if this time has passed, we're going to move the snake, and then we'll actually need to reset our start time. And there we go. That should be everything we need. Yeah, we don't need this right now. Let's try this out. There we go. And if I press the keys, see, it moves around. And now I can actually move off screen right now. You see? Because we didn't tell it to die if it moves off screen. And it doesn't actually interact with the food yet. So those will be your next steps. So in order for the snake to gain length every time it eats, we need to write an eat food function. But every time it eats food, the tail of the snake stays put while the head keeps moving forward. So what we need to do is have every position move forward, but then create a copy of the tail position and put it in the old position. Hope that makes sense, but it should be clear in a second. So we will need to keep track of these positions, and we will write these down before we move. So this would be positions at 0. And then the tail position will be the last position in the array. So this would be positions.size -1. Now these will be very important for the eat food function. Because when we eat food, we'll be adding a new position to the array, and this would be the previous tail position. Since the eat food function will be called right after the move function, since if we move into the food, we're going to be at the food position and we can now eat it. And so to eat food, we actually need to detect eating food. So this would be in our snake game function, detect eat food. And this is pretty simple. We just need to know if the snake is at the position, food position. But we also need the food to disappear, so we will set the food position to -1, -1. Generate food. Do we move? Detect eat food. And we also need to generate more food too, because we want to generate food. Actually, let's do that after. So we can generate food right after we eat it. So now we go back to the snake class, and we need to modify this move function. Since now we can be more than 1 square long, we need to move every position in our snake forward. So now the head will become its previous position plus the direction it moved in. And while we're in here, we might as well add the code to check if the snake has died. So we'll write a function later, check for death. If this is true, we'll need to reset the snake. So we also need another function, reset snake. And we can actually reuse this here. And we also need to add a positions.clear because we want to make sure the snake goes back to being just 1 long. So in order to check for the death, we need to see if the snake is out of bounds or if it ate itself. There we go. So now we're iterating through the second position in the snake through the last position and seeing if it's equal to the head of the snake. Okay, so I ate, and there we go. Look, our snake moves around, and it hits the food, it gets longer. Cool. And if I hit myself, it starts over. If I go out of bounds, it also goes over. Or game starts over. Oop. Cool. And like I said before, you can modify these parameters to make the game bigger or go faster. So we can do that now. So we can make the game, let's say 16, and up the game speed a bit so it goes a bit faster. So now you have to have quicker reflexes, especially with those edges. Fun. Well, thank you all for watching. I hope you enjoyed it and got something good out of it. I'll be making more games in the future that will be more complicated than this, so stay tuned for those. Thank you.